Okay, so if you've programmed, especially if you've programmed in other languages before that are more rigorous with data types, you may be used to giving a specific type declaration as you define your variable. So in Java, you might be used to saying, I'm about to store a number, and I want it stored with this much precision. I'm about to store a string, and I want it stored with this much precision. And it's different depending on what data type you're defining. In MATLAB, that's not necessary. In MATLAB, if you type myvar equals 7.3, MATLAB is also automatically going to think, that's a number, I need to store it as a number. And it stores it as this double data type. So if I do myvar equals 7.3, I can then use class brackets myvar, which will check the type of that data and tell me what MATLAB has interpreted it as. And you'll see it tells me that it's a double. If I do myvar equals test in quotes, this is the string data type we might expect, I can then do class of myvar, and it will tell me that it stored it as a char. Now this is a character array. This means that MATLAB is thinking of these words as list of characters. We'll see some more about that soon, but what it basically means is that the word test is actually a list that contains the letter T, then the letter E, then the letter S, then the letter T. So it's a list of char data types. But just be aware that doubles, numbers, char is going to be your words, your strings. And you can use class to check what data type MATLAB has interpreted things as. And we'll come across converting data types in a bit as well. The other way, obviously, of checking what data type something is looking at the workspace at the bottom. And if you have the class column selected, you'll see exactly the same thing displayed there as you would from typing class here.
Was this class double? What is it exactly?
Double is about how much memory is being used to store your number and the amount of precision. There's a bunch of data types. Integers are just whole numbers. You might not want positive and negative numbers. You might want it stored with 8 bits of memory or 16 bits of memory. So it lets you control how much precision, the sort of trade-off between precision and the amount of memory, which shouldn't be a problem. Everything you can consider everything a double for now, and that's totally fine. That just means you've got lots of precision. It can be positive, it can be negative, it can be very big and very small. And it also means it uses quite a lot of your memory, but it's very insignificant unless you're working with large quantities of data. So if you start doing whole genome stuff and you find you're running out of memory, then we're going to manipulate this stuff and not store things as doubles, because we don't need all the positive and negatives, and we don't need some of that memory used. But a double is a sort of safe way of storing a number that could be huge and could be tiny. Oh, and here are the others. So singles means single precision. You're not going to use those really. Double is it's the default. Logical data types will be true or false values. In MATLAB, they can be ones and zeros as well. We'll see some more examples of that later. Char, we've just seen when I defined that string that contained the word test. That's a list of characters. Be aware that MATLAB thinks of words as sort of lists of letters, and we're going to see some more examples of that too. Cell array is a very useful data type which allows you to store lots of different data that may have lots of different types or lots of different dimensions, all in one format. So if I want to store some numbers, some short lists, some long lists, and I want to store them all together, you can use a cell array to do that. We'll see some of that in a second. They're very much just like the matrices we've been working with already. The only difference is they can have different data of different dimensions at different places. Structures are more advanced, so you might create a structure representing your organism and then give it some properties. We'll see that later. And then the other ones you're probably not going to need to worry about. If you really get on to managing your memory and trying to optimize the speed of your code and how much memory it uses, this is where things like int 8 and unsigned int 32 come in. That's about really optimizing a number to use the very minimum amount of memory possible while still being able to store the data you're interested in. So only worry about that if things get really advanced and you find yourself running out of memory. But for now, you're going to be storing your numbers as doubles and your words as chars, and that will be the main thing we need to worry about here. And that honestly covers most computational biology applications. Your values for your data, your experimental results or your simulations are all going to be doubles that represent the magnitude of your data, and then your chars will all be the strings that represent your time points or the descriptions of your data. So I'm going to create another script just to explore data types a little bit. It's going to be called datatypes.m, and I can either hit new script and save it as datatypes.m, or I can type edit space datatypes.m. It will create a new tab in my editor window with the title datatypes.m, and then I'm going to define a few lines. I'm going to define a gene name to be my favorite gene, NF-kappa B inhibitor alpha, so NF-kappa BIA, in quotes. Notice I've got a semicolon on this line because I just want to define the variable. I don't want it printed to the screen yet. On the next line, I am then going to print it to the screen using the disp function. So I'm going to display the gene name. Line 3 will create a double with some expression value for my gene. So gene expression equals 367 point something. And now we can see how to convert data from one type to another. So if I do double gene expression, what it's going to do is it's going to try and convert whatever data type gene expression was already stored at to a double. Now it happens in this case it was probably already a double, and I'm converting it from a double to a double, which won't have any effect. But be aware that you can do this and it won't computationally impact your code too much to double check that your data is stored with the correct type. Now let's say I just want the integer representation of that number. I can use int val and create a variable called int val that stores uint32 of gene expression. We saw, so take that off the screen while you're copying. Whoops. We saw that's one of these things at the bottom, which stores numbers as a different type. So rather than converting to a double, I'm going to convert to an unsigned integer that uses 32 bits. You don't need to worry about the details of that. What's key here is that it's an integer. So I'm converting my gene expression value, which was a double, to an integer using uint32, and I'm saving whatever that conversion result is to a variable called int val. Now all I want to do is display double val and display int val. So print the double to the screen, print the integer to the screen. And then the final two lines are going to print the results of checking whether it's an integer. So the last two lines might look a little complicated, but what we're going to do is work from the innermost brackets out. You'll see we start with double val here, and then as we work out from the brackets, the first thing we do is run isInteger on that. And that's a MATLAB function to check whether a variable is an integer. So is it a whole number? Is it one of our integer data types? That will be true if it is and false if it isn't. And then I'm going to use disp to display the result of checking whether it's an integer. So as we work out from our brackets, we see that we check if it's an integer, and then we display the results of doing that. And then the final line is very much the same. I'm going to use my int val this time. I'm going to check if it's an integer, and I'm going to display the results of checking if it's an integer to the screen. So when you've written all that, save it, run it by either hitting the big green run button or typing data types and hitting enter in your command window. And you should see, firstly, the gene name printed to the screen, because we have this line disp gene name. Then you should see the double val printed to the screen. The only things that are going to be printed to the screen here are lines that start with a disp. Then we should see int val printed to the screen. And you should see that that is actually the integer version of the double that we started with. So you'll notice that it's rounded the number from 367.54 to 368. So when we disp int val, what we're actually seeing is this whole number, 368, printed to the screen. Now the last two lines are true and false statements, because is integer is either going to be true or it's going to be false. And in MATLAB that means they're either going to be 0 for false or 1 for true. So is double value an integer, is what this says. Is integer double val? Well, no, it's not. It's a double. It's not an integer. It's not a whole number. It's got a load of decimal place information. So that's false, which is why this 0 is printed to the screen here. The next line, is int val an integer? So is integer int val? Yes, it is. It's a whole number. There's no decimal place information, so it displays a 1 for true. And the reason it is an integer is because we converted it to an integer up here. We converted the variable gene expression to uint32, stored it as int val, and then we checked whether it was an integer on the last line, and it was.
I just have a general question. So if you don't have the semicolon in the display, would actually have to write the command display, correct?
Yes, if you have semicolons, nothing is going to print to the screen unless it's a print statement or a display statement with disp. Those will still print to the screen.
So if you got rid of display double val, but just had double val equals double g expressed without the semicolon?
That would work too. So the alternative to having these separate display statements is to just remove the semicolon from the previous lines.
So I don't know if there's like a benefit or value to the display.
What it is better to break up your display code from your sort of processing code. So when you look at this code, say you come back to this in a month's time or you give it to someone else, it's very clear that you're deliberately printing these to the screen. You didn't just forget the semicolon. When you're developing and you're debugging, it's quite common to take semicolons off just to see some output and figure out what's going on and then add them back when you're done. But if you're writing some code and there's definitely always going to be an output needed and you always want it printed to the screen, it's best to make that clear with a display statement or a print statement so that people know, this is part of the code. I want it printed to the screen. It's not just debugging where I missed a semicolon. So it's more about just code readability than it is about anything else. It's not going to slow you down.
You're rounding it up to an integer, but
Right.
that's the way you write it for everything?
There's a bunch of them depending on what data type you want to convert it to, but you would write them the same way. So it's the previous slide. Here we go. If I wanted it to store as an 8-bit integer, I would do int 8. So uint32 is just one of these many data types. It's an unsigned integer. It just happens to be a sort of middle-of-the-road one that people often use because it uses a lot less memory than a double and still gives you a fair amount of precision.
What do you mean by unsigned?
Unsigned is basically about whether you can have positive and negative values, whether there's a sign before it or not. It adds a whole load more memory if you do want to store the number line in both directions than if you know it's going to be positive. So if you have something that is a magnitude fold induction that you know isn't going to be negative, unsigned is fine. It uses a lot less memory without losing any information you'll ever use.
The previous slide. I typed all the codes, but I found that the results is a ratio, not the sum.
So do you remember we showed format rat, which will make all your numbers ratios? If you go back to format short, so if you type format space short in your command window, then run your code again, hopefully things shouldn't be displayed as rational fractions anymore. They should be displayed they should be displayed nicely. Does that fix it? Okay, great. Okay, so here's some of the other commands that you can use. Is integer, we'll check whether your number is an integer. Is float, we'll check whether it's a float, which is a number with floating decimal place precision. So any number with a decimal place in is going to be a float. Is vector is going to be true if it's a multiple numbers rather than a single one. And is scalar is going to be true if it's just a single number. So we test that on this vector 1, 2, 3. So x is 1, 2, 3. Let's check whether that's an integer. It's going to be false because it's automatically storing everything as a double, even though there's no decimal place information there. MATLAB is automatically storing it as a double, just in case we need the decimal precision for that variable later. So we'll check if it's a float. It is. It's got decimal place information. Is it a vector? Yes, it is. There's multiple numbers there, so we're getting a 1 for that. Is it a scalar? No. It's either going to be a vector or a scalar, meaning it's either going to be multiple numbers or a single number. Here we have multiple numbers, so that's false. So here we see one of the tricks with MATLAB is that you need to be aware that it's by default going to store everything as a double. So everything is going to have decimal place information. I'm going to use the words float and double somewhat interchangeably. That means there's decimal places. It has enough memory stored ready to store decimal place information if it needs to. So it's going to presume that every number that you store, even if it just looks like an integer, has enough memory ready to store as a float. So it's going to be the float data type. It's going to be this double data type with decimal place information. So isInteger is going to be false unless we have run one of our uint conversion commands, for example. So just be aware that by default everything's going to be a double. And isVector will be true if it's multiple numbers. IsScalar will only be true if it's a single 1-by-1 number.
And you don't need to put the comma, right? Like you didn't use comma there?
No, exactly. So I would recommend always sticking with the commas. Here I've shown an example where you can actually put spaces between those things. You can actually do 1 space 2 space 3, semicolon, 4 space 5 space 6. It's the same way we did commas, so the spaces and commas are interchangeable. I prefer commas, it keeps things clear. But if you get code from other people, you might find that it has spaces rather than commas separating your elements within a row.